So my final myth is that thought contents can be detected from brain waves. Now this is the only item on my quiz where I've got a divergence of opinion. In fact, I've sort of got quite an even spread here. Over the years, I found 41% of people agree with this, but 38% disagree. It's roughly equal. And 21% sitting on the fence and saying, don't know. And in fact, this year, I got 55% disagreeing with it. It's only 2 years I've done this where I've had a majority of people disagreeing with this myth. So, well done this year. So what's happening? Well, why might we think this? What are brain waves? That's what I'm going to be talking about in this session. Well, we know that the brain is an electrical device, organ. I've shown you pictures of neurons in other lectures, and the way that they communicate is by sending electrical pulses from the soma, the middle of them, all the way down these axons to little terminal dendrites where they make a connection to another nerve cell. This electrical pulse has to travel along that dendrite. So it's travelling through space. And if we measure this, we can see these little peaks and pulses in electrical activity. Very fast, so over sort of this 5 milliseconds of this, we can see what happens is that if we present a stimulus at 1 millisecond, you rapidly get, at a certain point on the dendrite, what's called depolarization. The ion channels change and let potassium and sodium exchange across the membrane. And you get a little spike of electrical activity. But then it repolarizes and goes the other way. So you get a little electrical pulse that travels all the way down the axon. And you can measure this. And in 1924, Hans Berger recorded these little pulses of activity from the human brain. And he called them electroencephalograms, which literally means pictures of the brain's electricity, or electrical brain pictures. So it's called EEG. And ever since then, EEG recordings have been a major tool in investigating what's happening in real time in real living people. It's before we had functional magnetic resonance imaging. We used EEGs to record the electrical activity of the brain just beneath the scalp. But one important thing he noticed was that it wasn't just spikes. He noticed regular rhythmic activity. It seemed as if the brain almost pulsed with a particular set of frequencies. The first one he recorded, and here is an actual recording that he made from his recordings, he simply called alpha with the Greek letter A for the first one. Alpha waves. You may well have heard of alpha waves as a brain wave. And this is a recording of alpha waves. The top line on this graph is actually a recording he made from someone's brain showing an alpha wave, and the bottom line is a timing signal generated by his equipment, a regular rhythmic time pulse. And you can see how closely and almost how similarly the brain wave matches that frequency. It's changing in height, which we call amplitude, which is the strength of the signal, but the frequency is pretty close to that timing signal. Why was he measuring brain waves at all? In the 1890s, he'd been serving in the German cavalry, Prussian cavalry, and he was injured. He had an accident while he was riding. And many, many miles away, his sister, who he was very close to, had a feeling that he was in danger. And she sent him a telegram to say, "What's happened? Are you all right? I had this terrible feeling about you." How on earth did she know that he had had this accident? Telepathy? Clairvoyance? He was convinced by this occurrence that telepathy, knowing things at a distance, sharing thoughts, the close relationship he had with his sister had somehow enabled her to sense this thing at a distance. The trauma that was happening to him had been transmitted over a distance, and she had picked it up. He had been trained to be a doctor. He switched to study the mind, to become a psychologist, to work out how minds that could communicate over distances. He wanted to know how telepathy worked. And this was the early days of radio. Radio seems like magic if you've never tried it. If it's novel to you, things happen at a distance. Information can be communicated instantaneously, it seems, from one point in space to another. Could this be underlying telepathy? Do brains act like little radio transmitters and receivers? He was looking at the electrical activity of the brain, because when electrical pulses travel in space, as they do when they're travelling down a neuron, they generate magnetic fields, they generate radio waves.